friends, in today's video we are going to make a directional dodge system in game animation sample. We are going to use motion warping in order to do the distance calculation for the montages. And yeah, this video is going to be a little complicated. So if you guys are able to follow me through the entire video, it would be nice. Okay, you can easily understand how it is working because it is a little complex when compared to the previous videos like the slide animation and the other stuffs. Because we need to get all four location vectors of the from the character, like front, back, and left and right. Okay. Yeah, without further ado, let's get into the video, okay? First, yeah, I've already made the system, so I will explain how it is working. First, we will go for the movement report column and yeah, get the input scale vector values of x and y. We will convert it into a variable, like we can just right click it and promote a variable, okay, and I named it x and y, okay, and just basically I'll explain what is happening over there, okay. uh, I'll give an input, uh, what shall I give, maybe right mouse button. Yeah, right mouse, I will give right mouse button, and if I use a print string, okay, print string, and if I give x over there, okay, yeah, basically what is going to happen is if I was, wait a second. Yeah, if I move forward, it is 0. If I go backward, it is 0, still 0. If I go left, it's -1. And if I go right, it's 1. Okay. Similarly, if I give y over there, uh, if I go forward, it's 1. If I go backward, it is -1. If I go left, it is 0. And if I go right, it is 0. Okay. Yeah, Y represent the forward and backward directions, and X represent your what your left and right direction. Okay. Yeah. So after promoting them into a variable and getting over there, getting over to the yeah dodge system, okay, I just gave a random input key R, okay, for and I will explain it to you later, okay. First, just make sure it directly goes to the dodge system, okay. Okay, dodge system, and inside the dodge system, okay, as you can as you have already seen, okay, if x is 1, okay, which is greater than 0, he'll move to the right side, and if it is -1, he'll move towards the left side, okay. And similarly, if y is 1, he'll move to the forward direction. And if it is -1, he'll move towards the backward direction. Okay. So I will set these into a separate Boolean variables. Okay. It'll be useful later. And yeah. Uh, the next thing is I need all the locations, start and in like starting location and ending location. Okay, for creating a like motion warping system. I'll show it to you in a second. Okay, in order to get the motion warping like in order to get your motion warping working, you need the target location and target rotation. The target location is going to be the end location, and the target rotation is going to be your start location. Okay, uh, yeah, start location. Okay, if I get in there, the start location is going to be your actor's location, and the target rotation is going to be your actor rotation. And in order to get your end location, first you'll create a forward vector. This thing looks a little messy, but yeah, you'll get a forward vector. Okay, basically forward vector represent. I'll again show you in a separate hidden graph. Okay, where is that? Okay, just right mouse button. Sorry, right mouse button. Okay. Uh, print string. Okay, no, I'll just give a spare trace. Okay, by channel. Okay. For get actor location. Okay, if this is the actor's location, which is of course I'm giving it to the starting point. And for the direction, the ending point, get actor or the okay. I'll just give this, and first I'll get a forward vector, and from this I'll multiply it. Uh, this is I'm multiplying it. It is based on your distance. Okay, I'm just gonna give it a distance of what? No, I'll just no, I'll just add this and then multiply it. Okay. No, no, I will just I think okay. Wait a second. I just got confused. First, I have to multiply it and then add. Okay. Yeah, multiply it. Yeah. And then I'll convert it into a float. I'll give it a distance of 200. Okay. And then I'll just add it. Okay. And then put it in the end location. I'll just give it a value of 4 maybe. Okay, something for one for duration. Okay. And if I go there, you can see we are able to see the sphere trace going in the forward direction of our character. Okay, if I want that to go in the backward direction of our character, I'll just put minus 200, or in my case, what I did over there is I just gave the distance, a common distance. Okay, a common distance. I just gave it as the input. Okay, I just dragged and dropped it over there. I just created a new input variable, a float. Okay, named it distance, and then I pasted it over here. Okay, and then later, as you can see over as I'll be doing it over here. Okay, I just create another multiply node. Okay, and convert it back to float. And then I multiply it my minus one. Okay, and then if I put it over there, okay, you guys can see it is facing in the backward direction of our character. Okay, similarly, if I do it for the right vector, wait, okay, right vector, now it will face in the direction of our left side of the character. If I just without multiplying it to minus one, if I just put it over there, you can see it is facing our character's right direction. Okay, right side direction. Similarly, if I go over there, okay, you guys will have seen. Okay, for forward, I just added it and gave the location from the forward vector. And for reverse, backward, I just multiplied it by minus one and then added it and then sent it to the reverse. Okay, this condition. Okay, first, if with the forward, like yes, you can see if the thing is one, okay, if y is one, the cat will dodge in the forward direction. So I just gave it. If else, okay, the cat will dodge in the backward direction. If else, if x is one, okay, he will dodge in the right direction, and if x is minus one, he will dodge in the left direction. This thing isn't full completed because as you can see, it is only in the four axis. The rest, for example, forward left, backward right, backward left, I still haven't completed those. Okay, basically the principle is same. Okay, I will explain it to you in the next video. Okay, yeah, for left and right, I did the exact similar thing, and I just gave the starting and stopping location, and I created a new variable named the montage number, which is an integer type. Okay, which is an integer type. Okay, yeah, and gave it a value of 0, 1, 2, and 3. Okay, for 0 for forward, 1 for backward, 2 for left, 2 for right, and 3 for left. Okay. After this, I just for spear trace to channel, it was kind of shabby over in there. So in order to make things neat and in order to not to repeat these steps again and again, I just created another function named spear trace by channel. Okay. I gave the start, end, and the radius. Okay, radius. So you can change it outside. Okay, you can change it outside, like here, over here, in the start and the end location. Start location being your actor's location, and the end location being the calculated end point. Okay, calculated endpoint and the radius. Okay, yeah, you can see already. And I just converted in the hit result and the impact point. I did this impact point so that yeah, if I'll show it to you over there. Okay, if I go over here, if I press R, he'll stop right before he hits the location. Okay, that is why I gave impact. Okay, so after impact, I'll just send all these points to the return node. Okay, and then I'll go back to the event graph. Okay, if he actually hits. Okay, if actually he will hit. Okay, if the hit result is one, I'll just target the endpoint to the impact point. Okay, and the rotation being the same. If he doesn't hit anything, it will be the original end location. Okay, original end location, and I'll just give it all to a branch over here. Same, similar to there in the directional dodge over here. Okay, if yeah, if this part, okay, I just gave 0, 1, 2, and 3, okay. If 0, he's gonna play your forward montage. If 1, he's gonna play your backward montage. If 2, he's gonna play your right montage. And if it is 3, he's gonna play your left montage. And okay, if left montage, okay, I will just disable this for right now. Disable this right now. I'll explain it again, okay. What this thing is doing. Okay, I will just disable everything. Okay, yeah. So I'll just after disabling this, you can see if I move forward and press R, he's just randomly spamming doesn't work. So in order to prevent that, okay, while playing the montage, the dodging state will be true, and after completing the montage, the dodging state will be false. Okay. So if I like after giving these, okay, I'll just give these, okay, connect these to the completed and the running, okay, of the montage. Okay, if I and after doing this, okay, I'll just go towards the starting point of the graph. Okay, in here I'll create a new branch, and if he is not dodging, okay, only this branch, it will allow the entire system to work only if the dodge animation is not playing. Okay, only if he completes the dodge animation, it will start to like repeat the loop again. Okay, yeah. Now for the input, I just gave a random input R, okay? So I'm gonna create a new input which is specific for the dodge animation, dodge, okay? I'll just go in there, into the blueprints, where mm, yeah, I'll just go in there and create a new input. I'll just click on the duplicate it and call like rename it as Dodge, okay? And then I'll go inside the IMC sandbox, okay? And for Dodge, I will just press this button and click left alt, okay? Because I'm convenient with using left alt. You can keep whatever input key you want, which is convenient to you, okay? I'll just remove this and call IA underscore dodge. Okay. The arrow one, you have to take the arrow one. Okay. Yeah, I'll just compile this and you can see if I press Alt, he's doing the dodge animation. Okay. Yeah, he's doing the dodge animation. Okay. In the next video, I will just change the dodge animation according to the character speed. Okay. Right now, he's playing the same dodge animation and with in whichever the character speed is. Okay. The next video, I'll change the dodge animation and dodge distance based on the character speed. And the same thing goes for your character slide. Okay. Because right now, the character sliding no matter sliding the same distance no matter the acceleration speed which he is currently in. Okay, yeah, I will change that actually. Okay, based on the character's current velocity. Okay, okay, guys, thank you for watching this video. And if you actually really like this video, I would really recommend you to subscribe because I'll be posting content like this regularly without any intervals from now on frequently. So if you guys started to subscribe this channel, you will be able to view a lot of informative videos like this. Okay, thank you for watching this video, guys. We'll see you later. Okay, bye.